The mass of Jupiter is 2.5 times more than all other planets combined in our solar system. Jupiter is 11 times the diameter of Earth. If you consider Earth to be a dime, Jupiter would be the size of a big plate. It's interesting how the composition of Jupiter is similar to the Sun. It's about 89% hydrogen and 11% helium. Sun is composed of 78% of hydrogen, 19.8% of helium. The rest of the Sun is heavy metal. Also like the Sun, Jupiter is a ball of gas. It has no real surface. So why isn't Jupiter a star? Well, first, let's define what's a star. Astronomers say that star is a gaseous object which is massive enough to fuse hydrogen into helium in its core. If you want to learn more about how the Sun or the star fuse hydrogen into helium, please pause the video and click over here. The Sun does it, so it's a star, but Jupiter doesn't, so it isn't. Jupiter is 80 times lighter than the lightest star in the whole universe. So it would require 80 times more mass than it has now to be a real star. People call it a faint star, but it's not even that. But now let's look for a faint star. The faint star we were looking for is called a brown dwarf. So, brown dwarf is an object that is too large to be a planet and too small to be a star. They are roughly twice the mass of Jupiter, and they don't have the required mass to start the nuclear reaction. Brown dwarfs are thought to be formed by the same process as the Sun or a star does, from a collapsing cloud of dust and gas. However, when the cloud collapses, it forms an object which is not dense enough in its core to trigger nuclear fusion. It turns out, to get the fusion going, you need to squeeze hydrogen pretty hard. Planets don't have the oomph needed for this. But if you pile up enough material, temperature and pressure in the core rises, and they will reach a point where hydrogen fusion ignites. So let's try placing another star in the orbit where Jupiter is today. So let's take the smallest and the brightest star we have ever seen and slam it into Jupiter. It would be 100 times massive, 20 times bigger than Jupiter is. It would be a very dense object with 0.3% of the brightness of the Sun. So now let's see what effect it has on us. At the closest, Jupiter is 4 times farther than Sun is to us. So effectively there would be any impact on the life on Earth. So at its brightest, it would be 80 times more brighter than the full moon. It would be distinctively red because it's a cooler star than the Sun is. And even it would be clearly visible during the day. So if you wish you could live in a solar system with binary stars, hit the thumbs up button. Subscribe to our channel for future videos. This is our ongoing series, The Wonders of the Solar System. To show your support, share our videos, comment down below with suggestions, and stay curious, stay awesome.